Hello dear students, we are learning subject physics. In that chapter number 6, Superposition of waves. In today's lecture, we will see about the vibrations produced in a string. Student, in this case, consider a string of a length L stretched between the two rigid supports, and T is the tension acts on the string due to the stretching, and m is the mass per unit length of the string. It is also called as a linear density. Mass per unit length is nothing but the ratio of mass and length. Suppose the string having the mass as a 10 gram and length as a 10 centimeter, then mass per unit length of such a string as a 1 gram per centimeter. And here v is the velocity of transverse wave. It should be noted that the velocity of a transverse wave is always given by root t upon m. This is the formula for the velocity of a transverse wave. Now, if string is made to vibrate, then for this purpose, vibrator as considering as a tuning fork, a transverse wave can produce along the string. When wave reach to the fixed end, then wave get reflected with a phase change of a pi radian, and this reflected wave interfere or superimpose with a incident wave, and stationary wave form on the string. Now see these three figures. String can vibrate with a different mode of vibrations, and these different mode of vibrations are due to the different frequency. If string is stretched between the two rigid support and is a plug or vibrate with using the tuning fork which is placed at the center, then string can vibrate as shown in this figure. That is, it consists as a antinode at the center of the string and two nodes at the ends point. And if the lambda is the wavelength and L is the length of the string, then length of this form loop is given by is lambda by 2, and that length is nothing but L. Now here lambda by 2 is the wavelength of that half wave. We know very well for the one wave wavelength is lambda, then for a half wave it is nothing but the lambda by 2. Also, we know very well the distance between the two nodes is lambda by 2, means distance between node and node is also lambda by 2. So, here lambda by 2 is equal to L, then lambda is equal to twice L. Now, we have the equation for velocity v is equal to n lambda. Now, here we want to find the value of frequency, so n is equal to v by lambda. Then value of v is root t by m, and value of lambda is 2L. Then after substituting values of v and lambda, these equations or value of n become n is equal to value of v as a root t upon m and lambda as a 2L. That is 1 upon 2L, and value of v is a root t upon m. That is n is equal to 1 upon twice L under root of t upon m. This represents the frequency for the first mode of vibration. And this is the least or minimum frequency. that least or minimum frequency is called as a fundamental frequency. FF means fundamental frequency. And fundamental frequency is called as a first harmonic. Now, in second mode of vibration, suppose string is divided into two parts. म्हणजे ही जी लेंथ आहे, लेंथचे दोन पार्ट्स कन्सिडर करून आता ट्युनिंग फोर्क हा सेंटरला न ठेवता पहिला इकडचा जो पार्ट आहे तिथं प्लेस करायचा किंवा तिथला जो स्ट्रिंग आहे तो या ठिकाणी प्लग करायचा. म्हणजे अशा पद्धतीने प्लग केलं तर जो फॉर्मेशन येणार आहे किंवा जी वेव्ह या ठिकाणी फॉर्म होणार आहे त्याचं नेचर या पद्धतीने. मीन्स हियर the formation of the two loops in which the node is at the center and also at the two ends of the string. Then for this purpose, here the length of a string L is equal to lambda 1. Lambda 1 because here is a complete one wave, and one wavelength for the one wave is nothing but the lambda. Or also we know very well the distance between node and node plus node and node means node plus node and node. Node and node is lambda by 2 plus lambda by 2 we get as a lambda, but for second mode of vibration wavelength consider as a lambda 1. Now we have the equation for velocity. V is equal to n lambda. For first mode of vibration, frequency as a n1, wavelength as a lambda 1, but V remains constant. Now here we want to find the value of frequency for the second mode of a vibration. So n1 is equal to V upon lambda 1. Now substituting values of V and lambda 1 as a lambda 1 is equal to L, and we know very well the value of a velocity is nothing but under root of t upon m. Now substituting these values we get V and lambda 1 as value of V as root t by m, lambda 1 as a L. Now here I will arrange this equation in a such manner. N1 is equal to means multiplied and divided by 2 this equation, then the new form of this equation is in this way. Means this can be written as 2 into 1 upon 2L under root of t upon m. Now you know very well this term represent as a fundamental frequency, means natural frequency n for the first mode of vibration. Therefore n1 is equal to 2 times of n. Here this is nothing but the equation of frequency for a second mode, and which is 2 into n means multiple integral of a fundamental frequency which represent as a that harmonic. So it represent as a second harmonic and first overtone. We know very well overtone which is used to indicate the higher frequency, and this is nothing but the frequencies which are actually present in a given sound. Now for the next mode of vibration, for this mode, in case of third mode, there are 3 loops are formed. That is here 3 loops are formed, means 4 nodes and 3 antinodes. Now in this case vibrating length is given by L is equal to 3 lambda 2 by 2. Now how 3 lambda by 2? For this purpose we can see in this way. Add the distance between node and node plus node and node plus node and node. या पद्धतीचं आपण मागच्या आर्टिकलमध्ये पाईपच्या केसेसमध्ये पाहिलेला आहे की व्हायब्रेटिंग लेंथ पाठांतर न करता आपण अशा पद्धतीने ते लिहू शकतो. मीन्स डिस्टन्स बिटवीन नोड अँड नोड प्लस नोड अँड नोड प्लस नोड अँड नोड. नाव डिस्टन्स बिटवीन नोड अँड नोड इज λ/2 plus λ/2 plus λ/2 means here 3 times λ/2. But for third mode of vibration, wavelength is denoted by λ2. So means that is L is equal to 3 λ2 by 2. Then λ2 is equal to twice L by 3. Now for the velocity V is equal to n lambda for third mode represent as a frequency n2 and lambda as a λ2. Then we have the value of n2. So n2 is equal to V upon λ2. Now substituting the values, λ2 as a 1 upon twice L by 3 and value of V is a T by M. So n2 is equal to 3 by 2L into root T upon M. Then this equation becomes n2 is equal to 3 into 1 upon 2L under root of T by M. We know very well this represents as a fundamental frequency n. Then n is equal to 3n here represent as a n2 means for the third mode of vibration. This frequency represent for the third mode of vibration, and here 3 times n means which is nothing but the third harmonic and second overtone. Overtone is higher than the fundamental frequency. Now for the next mode of vibrations frequencies are, जर आपण पुढच्या मोडसाठी जर फ्रिक्वेन्सीच्या व्हॅल्यूज काढल्या तर त्या नक्कीच या पद्धतीने येत जातील. दॅट इज 4n, 5n, 6n and so on. Means this is frequency for the fourth mode, for fifth mode and for sixth mode. Then from this we can conclude that all harmonics are present. Then general equation for the frequency for each mode of vibration is given by Np is equal to P into N. This is for the each mode. Equation for the frequency for each mode of vibrations. Suppose P is equal to 1, 2, 3 means P running from in this way. Then N1 by substituting P as a 1, then N1 is equal to 1 into N. As a P is equal to 2, then N2 is equal to 2 times N. As a P is equal to 3 times N. Now in this case this 1, 2 and 3 represent as the mode of vibration. Means this is the frequency for the first mode, this one for second mode and this one for the third mode. Now 1n is nothing but the first harmonic, 2n is the second harmonic and 3n is the third harmonic, and second harmonic is nothing but first overtone and third harmonic is a second overtone. In this way means here 1, 2, 3 represent as the mode of vibration. Now another general equation for fifth overtone. Then equation for the frequency for fifth overtone is given by Np is equal to P plus 1 into N. In this way. Now Let us continue the next article, laws of vibrating string, from page number 147. We know the fundamental frequency of a vibrating string under a tension is given by the formula n is equal to 1 upon 2L under root of T by M. Here L is the vibrating length, T is the applied tension to the string, and M represent as the mass per unit length, and it is also called as a linear density. Now, from this formula, there are three laws of string. First law is law of length, second one is law of tension, and third one is law of linear density. Now, from this formula, we can also say that n is inversely proportional to the vibrating string, n is directly proportional to under root of T, and also n is inversely proportional to under root of M. Now let us see the first law as a law of length, which is related to the length. Here is given that n is inversely proportional to L. At that time T and M are constant. Means this can be stated as the frequency of a vibration of a string is inversely proportional to the length, as applied tension remains constant and M as a mass per unit length or linear density are constants. Here n is inversely proportional to L, means as n increases L decreases, means one value increases another decreases. Then this can be written as NL is equal to constant. Now second law is law of tension. Here n is directly proportional to under root of T, means fundamental frequency of a vibrations of a string is directly proportional to square root of applied tension. At that time L means vibrating length and M as a mass per unit length are constant. Means this formula can also be written as N upon root T is equal to constant. Next one is law of linear density. This is stated as fundamental frequency of a vibration of a string is inversely proportional to square root of M, as T and L are constant. Means M is here nothing but the linear density, means there is the change in or variation in the linear density, but applied tension and length are constant. In case of a second law, there is a variation or a change in tension, but here is the variation in mass per unit length. Now for this law, we know the first law of a length as N is inversely proportional to L. Then from these two statements we can write as the L into root M is equal to constant. Now this law is given as N is inversely proportional to 1 upon root M. Now if R is the radius and rho is the density of material of wire or string, then this formula can be given as N is inversely proportional to under root of pi r square rho. Now here the factor pi r square rho is how? Then for this purpose consider the string which having the sum length as a L and having the thickness, means this represent as a cross-sectional area. We know the cross-sectional area of wire as a pi r square. In this formula, pi is a constant, r is the radius of a wire or string, and rho is the density of the material of a wire. Now we have the density is given by rho is equal to mass upon volume. Therefore, mass is equal to rho into V. But here V is the volume. Volume is nothing but the area into length. Then this formula can be written as M is equal to rho into AL. Now we have the linear density, which is denoted by always a small m. It is nothing but the ratio of mass per unit length, that is mass upon L. Here the value of m is rho by L upon L. L get cancelled is equal to rho into A. But here A is equal to pi r square. Is nothing but the cross-sectional area of wire. So m is equal to rho into pi r square. In this way we got the value of m as a linear density rho pi r square. Therefore the third law is that, means law of a linear density is given by n is inversely proportional to root m. Then that is n is inversely proportional to under root of rho pi r square in this way. Now from this formula we can use two statements as n is inversely proportional to r and also n is inversely proportional to under root of rho. In square root there is r square, so it becomes as a r. Means fundamental frequency of a vibrating string is inversely proportional to radius of the string, and also the fundamental frequency of a vibrating string is inversely proportional to square root of density of material of a string. Now this is all about the laws of a vibrating string.